All right, let's jump right into this explainer. We're going to uncover exactly why our common sense is, well, deeply flawed, and how the rigorous science of psychology actually cuts through the noise to find the truth. It's a totally fascinating journey into the human mind, and this framework is honestly just incredibly exciting to unpack.
Here's our roadmap for today. We'll start with why psychology actually needs science, then look at 3 traps of human logic, explore the psychological research toolkit, and wrap up with the wild case of clever Hans.
So, part 1, why psychology needs science, moving beyond common sense. To kick things off, we've got to clarify what exactly we're talking about here, because, let's be honest, people mix these two up all the time. A psychiatrist? That's a medical doctor. They work inside a branch of medicine dealing with disorders, and they can actually prescribe medical and drug treatments. But a psychologist? They focus on studying patients, testing for disorders, and doing the talking and counseling. For our journey today, we are firmly planted on the psychological side, the actual scientific research and testing of behavior. The big takeaway here is that psychology is absolutely a science. It completely relies on objective research because, and this might sting a little, our everyday logic is just incredibly flawed. You can't just ask people how or why they acted a certain way. That's actually super misleading. Basically, common sense isn't all it's cracked up to be. All right, moving on to section 2, 3 traps of human logic and how our brains fool us. Before we get into how to do the actual research to find the truth, we need to talk about 3 massive hurdles that actively skew our daily logic. We're looking at hindsight bias, overconfidence, and the Barnum effect. Think of these as mental traps. They literally trick us into thinking we understand the world way better than we actually do. First up is hindsight bias. This is that classic tendency to believe, right after learning an outcome, that you knew it all along. Good old Monday morning quarterbacking. You've definitely done this. Think about when the tragic news broke about Chris Brown and Rihanna. Suddenly, everyone was claiming they knew all along he was a violent kid. But honestly, did they? Or is that just hindsight bias completely rewriting their memories after the fact? Trap number 2 is overconfidence. We naturally just assume we know so much more than we actually do. Look at this wild stat. 82% of US drivers consider themselves to be in the top 30% for safety. I mean, mathematically, no way. It is literally impossible for 82% of people to fit into the top 30%. But our brains confidently and incorrectly convince us that we are exceptional. And we see this exact same irrational overconfidence with new business owners. A staggering 81% of them predict their own business is going to be a massive success. But when you ask those same people about the success of their peers, that number plummets to just 39%. It's a perfect snapshot of how intensely we overestimate our own abilities compared to everybody else. Then we have the third hurdle, the Barnum effect. This is our tendency to accept super general, vague characterizations of ourselves and think, wow, that is highly accurate. It totally explains why we fall for horoscopes or those online personality tests that could, frankly, apply to absolutely anyone. We read a totally generic statement, and our biased brains immediately twist it to make it deeply personal. It's the exact reason you read a fortune cookie and think it was written specifically for you. Which brings us to section 3, the psychological research toolkit and designing fair experiments. So once we realize our own intuition is playing tricks on us with those biases, we need a solid fix. Enter the strict methodological toolkit psychologists use to find objective truth. Step 1, you've got to know your goal. You're either doing applied research, which means trying to solve a clear, practical problem right now, like figuring out therapies for drug addicts. Or you're doing basic research. This is exploring curious questions without needing an immediate real-world use, like, say, studying how kissing changes as people get older. Super interesting, sure, but purely driven by scientific curiosity. Next up, you need a hypothesis to test. A hypothesis just expresses a relationship between 2 variables. And a variable? That's literally anything that can vary among the participants in a study. A great everyday example would be theorizing that actively participating in class leads to better grades than not participating. Boom! You've got your 2 variables, and you've stated how they relate. But to test that hypothesis fairly, you have to figure out exactly who you're researching. We call this sampling. You need to identify a population and pull a representative random sample from it. If you want to avoid skewed data, and trust me, you do, you absolutely must gather a random, stratified sample that perfectly mirrors the wider population you're actually trying to study. Okay, so you've got your sample. Now you have to split them into 2 very distinct groups. First is the experimental group. These are the folks who actually receive the test variable. On the flip side is the control group. They do not get the test variable. They're just your baseline. They're so you can see if your variable actually caused any real measurable change. And the final piece of the methodological puzzle is random assignment. Once you have that random sample, you have to randomly sort them into either the experimental or control group to keep things completely fair. Whether you use true randomization or group matching, the entire goal here is to control for and eliminate any outside confounding variables so your data stays pristine and completely objective. Finally, let's hit Section 4, the case of clever Hans, methodology in action. Let's put this entire toolkit to the ultimate test with an absolutely incredible historical case study. This perfectly proves why we need these strict scientific controls. Picture this. There's a horse named Clever Hans. He is seemingly doing math and spelling out answers to simple questions by tapping his hoof. Now, he wasn't always right, but he was correct most of the time. And this completely baffled everyone. Teams of brilliant zoologists, veterinarians, circus trainers, you name it. Now, since common sense tells us that horses definitely can't do math, we really have to ask ourselves, how in the world did Hans get the answers right so often? What was the hidden, confounding variable at play here that literally everyone else was completely missing? Well, it wasn't until a psychologist named Oscar Pfungst stepped in and applied strict research methodology to the situation that the impossible mystery was finally cracked. Pfungst found the secret. Hans wasn't a mathematician at all, but he was highly, highly perceptive. It turns out Hans was picking up on incredibly subtle, unconscious body language cues given off by his owner, who was the one asking the questions. As Hans started tapping his hoof, the owner's tension would naturally build, and the exact millisecond Hans reached the right number, the owner's posture would subtly relax. That tiny release of tension was Hans's signal to stop tapping. Pfungst proved this by doing exactly what any good researcher would do. He introduced a simple control. He just hid the owner from the horse's view. And wouldn't you know it, suddenly Hans couldn't answer the questions correctly anymore. By controlling the environment and eliminating that confounding variable, the owner's visible body language, Hans's apparent mathematical genius just vanished completely. This story is just amazing, and it perfectly highlights why strict methodology is absolutely essential to cut through our own biases and find the actual truth. But it also leaves us with a wild thought. If a horse can read our unconscious signals that accurately, how often are your own subtle cues unknowingly influencing the people around you every single day? I mean, really think about it. How much of our everyday reality is being shaped by things we don't even realize we're doing?